Tom. Welcome back to India.
Thank you very much, Sid.
Tell us a little bit about Proton. Where did Proton begin? What are the different products?
Proton realized that there was an industrial commercial application for electrolyzers and producing hydrogen gas on demand worldwide to displace or complement delivered mode of supply, which has been historically used for a safer, more economical solution for their customers to make their own hydrogen on site, much like people have their own air compressors for compressed air nowadays.
So when did Proton begin?
Proton began in 1996 when they realized that there was a commercial application for a aerospace product. They realized it would be a timely fashion to simplify, lower cost the electrolysis process using PEM technology for commercial applications. So in 1996 they gathered some venture capital to make investment in starting a company and were able to deliver their first hydrogen product to the market in 1998, of which their product is still in the field today.
So prior to this, before it became commercial, what are the different kinds of applications that these same technology was being used in?
The electrolyzers or hydrogen generators were used in life support missions in both space and sea. The electrolyzers were mostly used to generate oxygen for life support for sailors and submarines, and the hydrogen was a byproduct that was disposed of or vented off. In our commercial products, the oxygen is a byproduct that's vented off, and hydrogen is the commercial product.
But the process in both of these, whether it's an application that is for either life support or a mission critical application, and what is going on inside the products that Proton is manufacturing, is it the same?
Yes, it's exactly the same technology and much of the same components and designs. Those that are going into submarines today is exactly the same electrolyzer technology that's going to our commercial products today. So the inherent reliability that's necessary for critical life support of submarines in the navies and our customers and military customers is the same reliability that goes into our commercial products. So customers can be assured that the product we're giving them is equal to or greater than in reliability and safety as our military applications.
Military specs, I think almost all over the world are known for the fact that they're the toughest grade. So if you can adhere or comply to the military specs, then a commercial spec will never be as stringent.
Exactly, and the electrolyzer we're using for generating oxygen for submarines, for sailors to stay alive, can be no more important than that, and yet that's the same product that's going into our industrial applications for customers that might be using hydrogen for generator cooling in power plants, or for chemical reactions in a chemical factory, or for heat treating in a metals manufacturing process.
So when these electrolyzers is being put inside a submarine, their life is depending, because that's where they're getting their breathing oxygen from?
That's right. The submarines usually go out to sea and stay beneath the surface of the water for more than 6 months at a time without coming to the surface. So all the air they breathe is being generated by the electrolyzers on board the submarine.
And these electrolyzers are being supplied by Proton?
Yes, they are. So we sell the electrolyzer module, not the complete system, but to the companies that integrate our electrolyzers into submarines.
So defense EPCs and integrators?
Correct. Yep.
Maybe broadly speaking, what is the technology? What is water electrolysis for hydrogen generation?
We use electrolysis is not a new invention. It's not a new technology. It was discovered by William Nicholson in the 1800s. We've just modernized the electrolysis process. Historically, electrolyzing water to produce hydrogen, oxygen, and gas for various purposes was done with a liquid electrolyte. What we utilize today is a technology that was developed by GE for the Gemini space program in the 50s using a solid polymer electrolyte, which means it's an inherently safer way of electrolysis because you have less fluids to worry about. But basically when you have water and electrical charge at these in this electrolyte, whether it be solid or liquid, you begin to disassociate water into oxygen and hydrogen gas. Now some of the advancements in the technology is how do we do this where it's safe, how do we keep the oxygen and hydrogen separated once it is produced, and how do we clean it up, purify it, or pressurize it for a useful application. And there's where Proton has more than 70 patents, making this technology much more advanced and separating ourselves from others that have been doing this for many years as well.
But the entire electrolyzer itself is not a patented design. This is technology I understand has been existing for a long time.
That's correct. We didn't invent electrolysis and we don't have patents on that. We only have patents in the uniqueness on how we deploy electrolysis in our commercial products. So how we generate the hydrogen and what we do with it and how do we clean it and pressurize it is what's unique.
And when you mentioned the solid electrolyte technology also has been around for what, I think the 50s or the 60s.
That's right. GE developed the technology, but it's the electrolyte, which is a solid polymer electrolyte, also known as PEM or proton exchange membrane, is a commodity product manufactured by the DuPont company and sells under the trade name Nafion. So Nafion is itself used for many other chemical applications, not just water electrolysis.
And the same product basically in reverse is how a fuel cell functions?
That's correct. We're doing a reverse chemical reaction of what most people know of fuel cells. Where in electrolysis, we're putting in DC current and water to produce hydrogen and oxygen gas. Whereas a fuel cell is a reverse. So under a DC load, like you switch a switch for a light bulb, in the presence of oxygen and hydrogen, that fuel cell will react the oxygen and hydrogen to produce water and electricity. So we're just doing a complete opposite reaction.
So one of the things I understand with the Proton's technology and the product that Proton's making for the hydrogen generators is the fact that it's inherently safe. Can you just expand on that a little bit?
Yeah, most people are concerned when you're generating hydrogen. They think that it's an unsafe reaction, it's unsafe because you got flammable gases. But what people need to realize is that in making it on demand, you don't have a large volume of the flammable gas present. It's being made as it's being consumed. So therefore, the hazards and risks associated with making your own hydrogen on a basis that's being consumed as it's used means the risk is almost negligible, as opposed to traditional methods of hydrogen delivery to a customer is traditionally with bottles or large vessels from a gas company coming to the site. Now you have a huge volume of gas that has the potential to leak and become ignited all at once, instead of just a small trickle stream that's being made as it's being consumed. And the fact that the technology with solid polymer electrolyte allows us to generate the hydrogen at the pressures and purity for direct feed to a customer's process, while the oxygen being generated is being exhausted directly to atmosphere, so we're not containing the oxygen. Many people think just because we breathe oxygen that it's safe. Oxygen is an oxidizer, which means it combusts anything in the presence of itself. So in many ways, the oxygen is more dangerous than the hydrogen. So here, the oxygen is immediately vented off, not contained within the system, and there's only a negligible amount of hydrogen on board at any one time because it's being whisked away to the process as it's being generated.
So it's really the concern with safety of hydrogen is when it's in a large volume, which in the case of the Proton hydrogen generators, it's never contained within the generator in a large volume.
That's correct. And from a controls perspective, since the oxygen is being vented to the atmosphere and only that small volume of hydrogen is on board being delivered to the process, the controls for safety are quite simple. For example, if power is lost, you don't have to worry about flammable or safety risks from occurring with having a mixture of the hydrogen and oxygen present, because the oxygen is already going to the atmosphere, and as soon as the system shuts down, the hydrogen, that minute amount that was on board to begin with, goes to the atmosphere. So there's really no significant risk of a fire because there's no fuel present.
One of the things that a lot of customers, and when it comes to hydrogen generation or production or hydrogen generators in general, is not just the safeties that your engineering team has taken into account, but what are the different certifications that you're adhering to?
Well, we adhere to all the international codes and standards that are predominantly accepted worldwide. The International Standards Organization, or ISO, as most people remember as, and the NFPA, the National Fire Protection Agency in the United States. So our products are indeed so safe that these two agencies our products are designed in accordance with those agencies and certified by third party for installation into general purpose ventilated areas. We have close to over 100 of these hydrogen generators installed right in the laboratories of universities, right beside students and professors working on their research. And it's a much safer solution for them than handling a cylinder of gas. One cylinder of gas is much more hazardous than a hydrogen generator that is producing a cylinder's worth of gas per hour.
And these would be even pretty high volume hydrogen generators, like to give a comparison, I think one bottle of hydrogen is 7 cubic meters of gas.
That's correct.
If with the hydrogen generators of Proton, where a 6 cubic meters per hour, that means one hydrogen cylinder of gas worth of hydrogen being produced every hour.
That's correct. And if you think about a customer who's using one bottle an hour, and in 24 hours, they're handling a tremendous amount of bottles. Now, by making their own hydrogen on site, they eliminate the handling of those bottles. They're no longer handling the risk of all that volume of hydrogen that it's itself poses a risk, but also the mechanics of handling heavy steel cylinders, the physical risk of injury that is eliminated as well. And the making of breaking connections, which always poses a risk of a leak of hydrogen, goes away because now all the piping is fixed. There's no more changing of valves and connecting of supply. It's all fixed.
That's very true. I think one of the things that people can probably envision or relate to is LPG cylinders. In India, LPG cylinders are very commonly used as a source of fuel, as a cooking fuel. And I think maybe once every month or once every other month you hear some sort of an explosion taking place, and it's primarily because the connection was not made right and there was a source of ignition. So I think it would be very similar. So it's something for people to relate to, that you're handling cylinders, there's always an inherent risk.
That's correct, because if there is a leak, that entire contents of that LPG tank or hydrogen tank could leak very quickly, engulfing an area with a very large flammable mixture that could ignite and explode. Whereas if you're generating the hydrogen as you're making it, and the rough magnitude of production rate is equivalent to, let's say, a cylinder an hour, you can only leak what you're making because you haven't banked any in a tank. A tank could leak all at once, and a hydrogen can only leak what it's making. And hydrogen does diffuse very rapidly, and if it's in a well-ventilated area that installed per the codes and standards, the hydrogen is diluted and disseminated much quicker than it would if it leaked off from a tank all at once. So the hazards and risks associated with making your own hydrogen is very small percentage as compared to handling your hydrogen needs with tanks.
So now shifting gears a little bit, let's focus on India. I understand Proton has been in India for a long time. You started in 1996, and your first generator of a commercial scale, or I should say industrial scale, was shipped around maybe late 2003, 2004 at a power plant.
In the United States, yes.
But in India as well?
Our first product to India was shipped to a power plant in 2005 or 2006.
Okay.
And that unit, those are two units that have been operating at a very large thermoelectric power plant since 2006.
So what has been your experience with India?
Well, even though we delivered product in 2006, that was delivered through a very large international industrial gas company. We didn't have any marketing or sales presence in India, and as a startup company in 1996, we had to conserve our resources and where we did our sales and marketing. So of course, initially it made sense to do our sales and marketing in the United States because that's where we're headquartered. We branched our sales and marketing into Europe and then into the Middle East and then eventually into some starting in China. We didn't really have local resources or even resources in the United States to focus marketing on India, until it became a point in time where not only, we always knew there was a market in India for our products, we didn't just have the resources to spread ourselves thin enough to cover India. Until about 3-4 years ago, we started investigating finding a good partner in India to represent us in the Indian market.
So you mentioned a good partner, that's very subjective, but I think if you can expand on that a little bit, I think that might also help explain why you've chosen MVS as your Indian strategic partner, more than just a representation.
That's correct. For probably 4 or 5, maybe even 6 years ago, we did have local representation, but they operated in the capacity more like a sales rep. They didn't have deep resources to market and sell and support our products from a service and sales perspective. So that was a lesson learned in India. We knew we had to have a partner in India that had the resources and the business similarities of Proton Energy Systems or Proton On-Site to support our products with the same kind of synergies that Proton has in the United States.
At MVS, we've been taking the Proton products and really making the Proton hydrogen generator as the heart of the solution, as we like to call it. Because if you don't have a way to produce your own hydrogen, well, then you don't have a solution. So that's really where it all begins. But then we also have to take into account that many of the customers may not even have the raw material or the feedstock that is to be fed into the hydrogen generators, things like a DI water system, a demineralized water system, maybe a cooling water supply. So if they might be wanting to go for a chiller which is isolatable, and they only provide a chiller sufficient for the hydrogen generator.
That's right, Sid. That's a very good point, because we could try to market ourselves in India from the United States and sell products into India, but in supplying demineralized water systems or chiller systems and compressor systems in India to complement an overall solution for a customer, we couldn't do that and be competitive when there's other companies in India that are supplying those other subsystems around the hydrogen generator. Therefore, without the presence and partnership with MVS, our competitors would be more successful than us because they have those partnerships. So partnering with MVS was a key piece of the puzzle for us to become successful here in India.
So Tom, in your viewpoint, and in, I would say reflective of what Proton's viewpoint is, how do you think the partnership is going between MVS and Proton?
Actually, that's a very common conversation we have back at Proton headquarters. That actually, I have fellow salespeople who actually brag about the relationship we have with MVS and wish they had equal capability in their territories as well. We have marketing and service support in China, which is like 10% the capabilities of MVS. We have similar in the Middle East, which is very good. And in Europe, we've had a good dealer there for a very long time. But as far as all-around engineering capability and integration into our solutions and the transparent communications back and forth with Proton and MVS is top-notch. It's, like I said, everyone is very jealous of the relationship I have with MVS in my sales territory area. So we found that MVS was a perfect partner because their business was very similar to ours, and that was to generate on-site gas for their customers. We realized that MVS would become a good partner because there's a lot of similarities and synergies in our two companies. Proton and MVS, their main business model is to help customers generate their own gas on site to make themselves more independent, less reliable on outside resources, to give them a more reliable and safer supply of all gases that are in our marketplace, in our product suite, such as nitrogen, oxygen, and hydrogen.
We are very happy with the relationship with Proton as well. I think really, from MVS's perspective, it's a top-notch product that's working at thousands of locations worldwide, and being able to support that product and build solutions around it gives our engineering team a lot of sense of pride. And they believe that now they're finally working with a good hydrogen generator that's going to work, and it's going to work well, because MVS in the past has never ever put its name on a product that it cannot stand behind. So with Proton, we have that level of confidence, and I think I see this relationship going well into the future and maturing maybe at a very different level, and that's something we all look forward to here at MVS.
And I would completely agree. In fact, we've even, and you recall this, we've had conversations about the potential for doing some final assembly and manufacturing here, even in India in the future, once the volume of our product in this region will support such activities, where that level of conversations have been really, there was questions asked, but we never fully, even entertain the question in other territories or with other partners like we have here with MVS Engineering.
Very good. Well, thank you so much for your time. And
it was my pleasure.
Look forward to doing lots more business with Proton.
Yeah, let's hope so.
Thank you.